Hi, hello, vanakkam, and welcome back to another episode on your favorite Little Star YouTube channel. So today we're going to see about throughput, and it's not just throughput; it's about throughput, which most people don't know. Yes, we're going to discuss those topics. We're going to touch base on that what most of the people do not know about throughput. So let's talk about throughput in performance testing. So now most folks think throughput is just means requests per second or transactions per second, right? So that's how I think, and that's how most of us think. So, but here's the thing: there is a whole hidden world behind the throughput that we often miss, and that's why we're going to see today. So there are like 10 rules which you're going to see today in terms of throughput. So the first thing is throughput is not only about how much load you push. So it's actually a combination of your workload, your server's capacity. So let me give you an example. So imagine you set JMeter to test or to fire 10,000 requests per second. And if the backend can only handle 1,500 per second, and that's where your throughput flatlines, right? That's where your throughput ends. So no matter how hard you push, that's where your throughput is going to flatline. The second point is throughput and latency have a love and hate relationship. So what is this love and hate relationship? So when the throughput climbs too high, your latency often shoots up. So it starts like the queue starts building and you will notice throughput plateaus, but response times go from milliseconds to seconds. So the classic queuing theory at play, which is the Little's law, is in action now. And the third point is when more users, more users don't always mean more throughput. So take for example, think of a nightclub with one bartender, and after a point, adding more people just makes the line longer. The drinks don't come out any faster, and that's exactly how throughput behaves beyond saturation. So previously we used to discuss this with the petrol pump example, right? So now I'm giving you a different example. And the fourth one is throughput is not the same as bandwidth. Most of us confuse this because bandwidth is like the width of the highway in megabits per second, but throughput is the number of cars which are actually moving across, which are the requests per second. So sometimes your test hits a ceiling not because of your CPU but because of the network lane is full, and I think now it makes sense. And then the fifth one is the pattern of throughput, which is degrading your performance. So the pattern of throughput degradation, which will tell you a story. If the throughput slowly drift downward, right, you might be leaking some memory. There could be some memory leaks, or there could be some thread issues, like the threads could be starving for more threads. If it suddenly drops, that is usually the database locks or connection pool exhaustion. If it stays flat even when you add more load, you might be hitting a load balancer or a rate limit, and this is what happens with respect to the throughput. And let's now go to the sixth one. So think time in scripts changes your throughput dramatically. I used to discuss this lots of time just to check on the think time, because for example a script with a 10-second think time will never max out the server because users are waiting in your test, and if you remove your think time, and suddenly you will see the real limit of your backend. And now the seventh point is throughput is uneven across endpoints. Yes, 80% of your throughput often comes from just 20% of your URLs. Yes, so if you only report the total throughput, you might miss the fact that says the checkout API is bottlenecked while the search is flying. So that's the reason you have to check for the throughput. And then the eighth one, which is the protocols matter. Yes, with HTTP2 multiplexing, you can sustain way higher throughput with fewer connections compared to HTTP 1.1. Yes, there is a difference between the HTTP2 and HTTP 1.1. And if you're using gRPC, you might push double the throughput with less overhead. And most testers never compare throughput at the protocol level. Yes, but it is supposed to happen, but most of testers never compare the throughput at the protocol level. And now the ninth point, which is the raw throughput does not always equal your business value. For instance, One login transaction per second may be far more critical than 1,000 image requests per second. So if you're optimizing the wrong throughput, it's like tuning your car's air freshener instead of its engine, because you're tuning a different part of your car which is not supposed to be helping your performance. And the 10th point, which is the hidden throttles. Sometimes your CDN, your content delivery network, or your WAF, your web application firewall, silently caps the throughput. Yes, they will do it. You think the app is slow, but in reality the edge layer is holding back the request unless you check the logs outside the app, which you will never know. And now I'll end up with a quick pro tip. So watch for the throughput collapse point, and that's the moment when the throughput stops rising, or it will even drop while the load continues to increase. And that's your system's real breaking point, which most testers ignore it, but the best testers will hunt for it. So if you're a best tester, you will definitely hunt for it. So next time you look at throughput, don't just see it as a number, or don't just see the number. See, it is telling you a story. It is telling you where your system bends and where it is gonna break and where it silently throttles. So thank you so much for watching this video. I'll come up with more interesting topics like this. See you all very soon. Take care and bye bye.